Hi you guys, this is the video that's going to cover example number 6 from today's in-class notes. So I would watch this if you take a look at the problem that involves the airplane, number 62, or the problem that involves the boat, number 31, and you're not quite sure how to get started. So let's take a look at this example and we'll see how we can do the setup so that we're just using information about what's going on with how fast something's moving in still air or how fast something's moving with a current. So in this problem, it says Casper the Friendly Ghost and Wendy the Good Witch, because they're on our Halloween theme, flew on a broomstick from one city to the next. With a tailwind, their broomstick averaged 158 kilometers per hour. On the return trip, the broomstick only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the broomstick in still air. So if we take a look at this problem, it's asking us to find the speed of the wind and find the speed of the broomstick. So that right there is going to be our variable definition. We can say x equals broomstick speed, if that's what you're flying on. If you're flying on a plane, it would be the plane speed. If you were navigating a boat, it would be the boat speed. Then y is going to be the wind speed. So if we take a look at a problem like this, what it says is that they're starting out with a tailwind. So a tailwind means that the wind is behind you, it's helping you to move. So you're going to be going faster. So if you add the speed of the broomstick and the speed of the wind, that's going to be how fast you're moving. So our first one, we can say we have one equation that comes from flying with the wind. So that's going to be x plus y is equal to our speed of 158 kilometers per hour. Then when they come back, they're flying into the wind. So this is just like if you imagine running. If you run into the wind, it's more challenging than if the wind is helping you, because then the wind is trying to slow you down instead of trying to help speed you up. So here, this one is going to be into the wind. So this equation, we're just going to subtract the wind speed. So x minus y equals our overall speed of 112. So that's all we have to do there. Then this kind of system of equations we can solve with elimination or with substitution. So let's use elimination and let's just subtract to find our values here. So what we have are x minus x, those values are going to go away. And then we have y minus negative y, this will become positive 2y. I know I'm a little bit off aligning my columns there. Then we have 158 minus 112, so our value there will be 46. We can divide by 2, and our y value, or our wind speed, is going to be 23 kilometers per hour. Once we have that value, it's going to be easy to solve back in, and we'll substitute for y there. So we will have x plus 23 equals 158. So to solve for this value, we'll subtract 23, and so then when we subtract that off, our broomstick speed will be 135 kilometers per hour. So we're going pretty fast on that broomstick speed here. So that's all that we're doing when we're working through this kind of information, is trying to figure out how fast is one thing going, and then is this the wind helping or is it hurting? Or in the case of a boat, is the current helping you move along faster or slow you down? Now, the one thing that's different about problem number 61, if that's the one that you're trying to solve, is that this one is asking you to work with distance equals rate times time. So here, we were just working with rate. So all of this information dealt with rate, all of this information dealt with rate. So just as a quick sample setup for that problem, if that specifically is where you're encountering some challenges, is that for number, 62. For problem number 62, it says a plane flew 1,000 miles in 5 hours. So that equation setup, 1,000 would be the distance. The rate with the wind is going to be x plus y, and then the time is 5. So you still have x plus y to represent the rate, but you're actually solving for the distance there, not setting it equal to the distance like in this one. Same general problem solving practice though. Please email me if you have any questions about these. And also just know that we're going to be practicing with these tomorrow and on Wednesday. So there's no more new material for sections 3.2. So if you feel like the problem solving process is pretty easy, but it's just the equation set up from the word problem that's challenging, then I wouldn't worry because we've got time to get to that and to practice with that. And then that's really going to be the only thing that you'll need to focus on. So please let me know if you have any questions tonight. Just shoot me an email if there's anything that's not quite clear in your work. Thank you, guys.